Video to remind you how to model mechanical systems in control systems, and specifically I'm talking about mass spring damper type systems, not rotating systems. So in these type of systems, what we need to remember is the rule that force is equal to the sum of impedances multiplied by x, which is the position. All right, so we have three components here. The first is a mass, or an inertia, if you will, and we can see that in the time domain, f of t, the force with respect to t, is equal to the mass times the second derivative of position. In the Laplace domain, that looks like f of s is equal to the mass times s squared x of s. All right, next we have a viscous damper, which I've represented as having a value fv. You may see other letter representations of this, perhaps b or d. All right, but I'm going to use fv. And what I know is that in the time domain, the force is equal to that damping coefficient Fv multiplied by the derivative of position. And so in Laplace domain, what that looks like is FVSXS. All right, and then lastly, we have a spring in the time domain that looks like f of t is equal to kx of t, the position. So it's just a linear relationship. And in the Laplace domain, it's also the same. F of s is equal to k x of s. So essentially, if I highlight my impedances here, it's ms squared, fvs, and k.